Welcome back to Summarize Science. Today, we're looking at a fascinating new soft robot that could change how we explore difficult environments. Imagine a tiny, ring-shaped robot that can jump over and over again, completely on its own, powered only by a steady light source. Researchers from North Carolina State University have created just that, and the results are pretty amazing. Let's break down how this little jumper works. As you can see in these diagrams, it's made from a special material called a liquid crystal elastomer, or LC, bent into a ring. One end has a rigid, triangular tail made with a small aluminum tube. When placed under constant infrared light, the LC material heats up and twists, storing up elastic energy like a wound-up spring. Then, in a fraction of a second, the tail snaps against the ground, releasing all that energy and launching the robot into the air. But here's the clever part, the reset mechanism. While it's flying through the air, the twisted body naturally untwists, getting it ready for the very next jump as soon as it lands. This means it can leap continuously without any external control, latches, or needing the light to be turned on and off. The researchers didn't just make it jump, they figured out how to control how it jumps. By changing the sharpness of the tail's angle and the intensity of the light, they can make the robot perform different moves. As shown in this phase diagram, it can switch between powerful vertical jumps, long horizontal leaps, and even just crawling along the ground. A sharp tail angle, for instance, allows it to store more energy for a super high vertical jump, reaching over 80 times its own body height. One problem with tiny jumpers is that they can tumble uncontrollably. To solve this, the team took inspiration from nature, like grasshoppers, and added a tiny weight to the robot's head. This simple trick shifts the center of mass forward, which stops the robot from backflipping and allows for stable, directional leaps. They were able to achieve controlled horizontal jumps of over 3 body lengths. Of course, the real test is how it performs in cluttered, messy environments. The researchers put it through an obstacle course, and it showed remarkable resilience. It can cleanly leap over hurdles, or even use a collision with an obstacle to push off for an even bigger jump. It also successfully navigated diverse natural terrains like grass, wet sand, and mulch, adapting its movement to each surface. So, to recap, the researchers have created a millimeter-sized, self-resetting soft robot that jumps autonomously and continuously under constant light. Its movement is highly tunable, and a simple weight adjustment makes it stable and directional. This work establishes a new way to design soft robots that can recycle energy from their environment. In the future, swarms of these tiny jumpers could be used for things like environmental monitoring, exploring unstructured terrains, or navigating inside complex machinery where larger robots can't go. It's a huge leap forward for autonomous soft robotics.